Okay, now very quickly in this very short video, let's give a look on how ACI loop detection works. Basically, I'll be talking about the layer 2 loops, how they can be detected and mitigated. So there is a policy, we can create a global policy which can help us detect layer 2 loops which might form at the access ports. By default, these policies are disabled, but at port level, this is enabled. The policy I'm talking about here is the MCP policy, the miscabling protocol policy, which is configured, which is disabled by default, but at the port level, it is enabled. Actually, by global, it means the loop detection would be enabled on not just ports, but on virtual ports and port channels as well. So when I say by default these policies are disabled, that means it is not active on any of the ports throughout the ICF fabric. And at the port level we can enable it. So at the port level it basically means we can enable at both the port level and the port channel. So the port channel and VPC are the not the physical ports, they are the kind of a virtual ports. So we can we have an option to enable MCP protocol over the port channels and the VPCs as well. Now a very important point for ACI is that it does not take part into spanning tree, as we all know that. Instead, it implements miscabling protocol to detect loops. MCP runs on the native VLAN where VLANs are not tagged by default. Now what happens is if the fabric receives the packet back on that native VLAN, then it considers a potential L2 loop and hence blocks or drops the packet. For more details on how MCP works, you can check out this link that the Cisco link that I've shared on the link for more details on MCP protocol.